Have you ever looked at a world map and noticed how South America and Africa seem to fit together almost perfectly? It's one of those quiet mysteries you might have wondered about as a child and dismissed as coincidence. But what if I told you? It's no coincidence at all. The shapes of our continents, the mountains that pierce the skies, and the oceans that divide them are not accidents of nature. They are chapters in a breathtaking story written by the planet itself, a story of fire, pressure, time, and motion that began billions of years ago, when Earth was born about 4.5 billion years ago. It wasn't the blue and green planet we know today. It was a violent, molten world, its surface, a swirling ocean of lava. For hundreds of millions of years, meteors rained down, volcanoes erupted endlessly, and the planet's crust formed, broke, and reformed. Slowly, the outer shell, what we now call the lithosphere, cooled just enough to harden, but it didn't form as one solid piece. Instead, it cracked into massive slabs known as tectonic plates. Beneath those plates, hot molten rock in the mantle churned and flowed, pushing the surface above it like slow-moving conveyor belts. Those plates became the architects of our continents. The relentless, invisible motion of these gigantic plates shaped everything we know about Earth's geography. Mountains rose, oceans opened, and continents drifted inch by inch, year by year, across millions of years. If we could speed up time, our planet's surface would look alive, constantly shifting, bending, breaking, and healing itself. Around 3 billion years ago, the earliest known supercontinent formed. Scientists call it Valbara, a name that feels ancient because it is. Over time, Valbara broke apart, and new supercontinents formed in its place. Your Kinnerland, Columbia, Rodinia, and Panotia. Each lived for hundreds of millions of years before being torn apart by the restless energy inside the Earth. But none of them have captured our imagination quite like Pangaea, the great supercontinent that existed around 335 million years ago. Imagine looking down at Earth during the time of the dinosaurs. Instead of 7 continents and 5 oceans, you would see one gigantic landmass surrounded by a vast ocean called Pangaea, stretched from pole to pole deserts in its interior, dense forests near its edges, and coastlines teeming with life. But even then, deep beneath its surface, the seeds of its destruction were already planted. The same slow churning of magma that built Pangaea also began to tear it apart. About 175 million years ago, cracks appeared along fault lines, and magma began to rise from deep below. The ground split. Oceans began to form in the cracks. The mighty supercontinent started breaking into pieces, first into 2 enormous landmasses, Laurasia in the north and Gondwana in the south. From there, the process continued, slowly giving birth to the continents we know today. If you could play this process like a time-lapse video, you'd see South America gently peeling away from Africa, leaving the Atlantic Ocean in its wake. You'd watch India, once a small piece of Gondwana, speeding northward faster than any other continental plate, crashing into Asia with unimaginable force. The collision pushed the land upward to form the Himalayas, the tallest mountains on Earth. Even today, the Himalayas rise about 5 millimeters every year, living proof that the continents are still on the move. Meanwhile, Antarctica drifted toward the South Pole, isolating itself in cold ocean currents that sealed its icy fate. North America and Eurasia twisted into their modern positions, constantly reshaped by earthquakes, volcanic eruptions, and erosion. What's incredible is that the Earth is still shifting. Every mountain, valley, and coastline is temporary, a momentary shape in the grand timeline of the planet. If you were to look at a map 100 million years from now, it would look nothing like today's world. The continents are still moving at roughly the speed your fingernails grow, around 2 to 5 centimeters a year. Over time, those centimeters add up. Scientists believe that hundreds of millions of years from now, the continents will drift together again to form another supercontinent, a future landmass some scientists call Pangaea Proxima. In that faraway time, Africa may merge with Europe, closing the Mediterranean Sea forever. The Americas might slam into Asia, forming a colossal new mountain range. The Atlantic Ocean, which separates the old and new worlds today, could vanish completely. This constant motion beneath our feet shapes more than just geography, it shapes life itself. The movement of continents affects climate, ocean currents, and even the evolution of species. When continents drift apart, species are separated, and new ones evolve in isolation. When they collide, ecosystems mix and transform. The breakup of Pangaea, for example, created isolated land masses where dinosaurs evolved differently, giving rise to the incredible diversity of prehistoric life. Later, it set the stage for the rise of mammals, and eventually, us. Even human history is deeply connected to this slow-motion planetary dance. The mountain ranges that protect civilizations, the fertile river valleys that gave rise to agriculture, and the ocean routes that shape trade, all of them exist because of plate tectonics. The Himalayas, the Alps, the Andes, the Rockies, they are monuments to Earth's inner power. The story of continents is, in a way, the story of everything that ever lived. But let us pause for a moment and think about the shapes themselves, the outlines of the continents that we see on every globe and map. Those shapes are not random. They are fingerprints left behind by ancient events, rifts, collisions, erosion, and time. The smooth curve of Africa's west coast matches, the eastern bulge of South America because they were once neighbors. The island chains of the Pacific like Japan, the Philippines, and Indonesia exist because the ocean floor is constantly diving beneath continental plates, creating arcs of volcanoes. Even the deep trenches of the ocean, like the Mariana Trench, are scars where the planet is swallowing its own crust. If you could hold a map of Earth's future, it would show a very different planet. In a few million years, the Red Sea will widen into a new ocean as Africa splits apart. Australia is slowly drifting north and may, one day, collide with Southeast Asia. California is creeping toward Alaska, and the Pacific Ocean is shrinking. Change is inevitable. The Earth never stops moving. The continents are travelers, and their journey is far from over. Our planet has been shaped by immense power, by collisions that created mountains and rifts that opened oceans. But what is truly extraordinary is that all of this happens so slowly that we rarely notice it. To us, continents seem eternal and unmoving. Yet, beneath our feet, the Earth's crust is alive, shifting, bending, breaking, and rebuilding itself in a cycle that never ends. So the next time you glance at a world map, remember that you re-looking at just one frame in a movie that has been playing for billions of years. The continents we call home were once united, and they will unite again. Their shapes are not just outlines on a page, they are the traces of a planet in constant motion. The Earth beneath us has memory, rhythm, and purpose. It is the storyteller of time itself. And we are lucky enough to live on one of its most beautiful chapters. A moment in the endless story of how the continents got their shapes.